Okay, power. Basically, when you raise a base, when you have a power and it's being raised to another power, all you're doing is multiplying the two powers. So if I have x raised to the power 4, that's in parentheses, raised to the power of 3, you're really just doing your base of x raised to the power of 4 times 3, which is x times 12. Let's talk about why this works. If I have my base of x to the 4th, how many times am I doing x to the 4th? 3 times. So that means I'm doing x to the 4th times x to the 4th times x to the 4th. Well, now you're just now looking at a multiplication property. What do you do to these bases if you're multiplying what do you do to the exponents if you're multiplying all the bases? Add them up. So I have 4 plus 4 plus 4, which still gives me x to the 12th power. That's all you're doing. Alright, so let's try a few of these really quick. If I have, and these I want you to do on your board. If I have 7 to the power 4, that's in parentheses, I'm going to raise that to the power of 6. What will that give me? Hold up your board whenever you have it. You are so quick at this. 7 to the power of 24. Great. Ready for the next one? Watch out, there's going to be some sneaky ones. 3 to the power of 7 raised to the power of 0. I got some of you on this one. Anything raised to the power of 0 is going to equal 1.
Yes.
Alright. Next, I have, alright, watch out. It's just when you feel good. X to the power of 2 raised to the power of -4. Oh, wow. I didn't trick everybody. Remember, you cannot have a negative exponent. And if you're erasing that negative exponent, you need to put it somewhere else. So I end up with x to the power of -8. That's not okay. So I need to put this as a denominator, which gives me 1 over x to the power of +8. When it's a negative, I need to move it to the denominator spot, and it'll turn positive. Okay. Here we go. X to the power of 3 raised to the power of -5 times x to the power of 5. Try it first. There's a few routes you can take on this one. Okay. So, I see here I have 3 times -5. That's going to give me x to the power of -15 times x to the power of 5. When I add the exponents, I'm in a multiplication situation. Whenever I add the exponents here, that gives me x to the power of -10. Ooh, that cannot be, so I need to make it 1 over x to the power of +10.
No, I didn't get that.
Okay, what?
Why couldn't you just add the 5? Like, I added it first.
Okay, you're going to have to take care of. So think about this as being distribution. You want to distribute first. Okay. Okay. X to the power of 3, y to the power of -2, close parentheses, raised to the power of 4. red. I was trying to trick some of
What
y'all.
about the one?
What about the one? What one?
The one that can't be negative 8.
So I'm going to distribute my 4, that exponent. So that gives me x to the power of 12, y to the power of negative 8. I can't have a negative exponent, so that's going to go down to the bottom.
But don't you have to do with the negative exponent, right? What Caroline's note said is that you divide 1 by the base times the negative plus number.
Okay, but that would be fine. I can do 1x to the power of 12 over y to the power of 8, but do I need to write the 1? So that's, her notes are correct, but do I need to write it all the time? I only have to have that 1 there as if there's nothing else as a numerator. Let me give you one of those. Okay? All right. X to the power of 7, y to the power of 2, z, all raised to the power of negative 2. Next one's up. Okay, when you distribute that negative 2, everything's going to be negative. Don't forget, z has an exponent of 1, so I don't want to leave it out. So that gives me x to the power of negative 14, y to the power of negative 4, z to the power of negative 2, and I can't have negative exponents, so now I'm going to put all of those over 1. That's where the 1 needs to be written, is whenever you don't have a numerator, you're going to put a 1. X to the power of 14, y to the power of 4, z to the power of 2. Now we have all denominators. And all of my exponents are positive.